sometimes you're going to be given a set of coordinates and you're going to be asked to find the angle, whether it's in radians or degrees, that would pass through that coordinate when you're in the standard position of angles, which means you have 0 here and then it swings around that way. Okay, that's what we're referring to when we say standard position for an angle. So you have a coordinate plane here and you can use it, but I'm actually not going to use it much at all, if at all, because I'm just going to draw them. If I have an angle that goes through the coordinate negative square root of 2 over 2, comma, square root of 2 over 2, and you can be like, oh, what is that as a decimal? I have no idea, blah, blah, blah. Who cares? Who cares? Just put a dot. Let's put a blue dot. Whoa, my paper just ran away. Come back, paper. Here it is. This is negative, comma, positive. So negative square root of 2 over 2, comma, square root of 2 over 2. So this is negative square root of 2 over 2, comma, square root of 2 over 2. And what they're really asking is, and I'm going to switch colors here, what is this angle whose terminal side, so the side of the angle right here, this terminal side of the angle, passes through that coordinate. So I need to know what this angle is here. All right, well, how are we going to find it? Well, first of all, let me go ahead and tell you what the answer to this one is, because it's going to be fairly obvious if you look on your unit circle. We're going to put this one in radians and degrees. So I don't know what this angle is. Clearly it's in the second quadrant, but I'm looking for a coordinate of negative square root of 2 over 2, comma, square root of 2 over 2. It's on the unit circle. So this would be 3 pi over 4 radians. We could also say it's 135 degrees. Either one of those is going to be a sufficient answer. So my final answer for this one is that my angle is 3 pi over 4 or 135 degrees if you want to use both. Even though this lesson specifically is about radians, we have both in this case. Okay, if you're thinking, wow, they're all that easy, I can just look on the unit circle, they're not all going to be there. The next one is, so I'm going to also show you a different way of finding this exact same thing. So switching colors, and just going to kind of block that off. Let's deal with the fact that this is the angle, and from this angle, now to be technical, we could say from the origin, like if my angle is at the origin, often in a triangle, we'd say it's this little corner right here. We would have opposite and adjacent. All of these are going to be tangent. So the tangent of an angle is the opposite side divided by the adjacent side, and we're going to just solve that. So even though we have our answer right here, here's an alternate way of doing it. So we'll say that the tangent of our angle is opposite, which is square root of 2 over 2, divided by square root of 2 over 2. Whoops, one of them was negative. Oh, negative. There we go. So that's going to give me something divided by itself, but one of them's negative. So something divided by negative itself. So negative 1. So here's what I'm doing. I want to find where tangent is negative 1. So we are back to the unit circle now. Oops, let's write a negative 1. I want to know where tangent is negative 1. Tangent is negative 1 here. Now, it's also negative 1 here, but clearly, based on the coordinate they gave me, we are in quadrant 2, so we're going to come up here and say, oh, well, it must be 135 or 3 pi over 4. Almost said square root of 2 over 2. That's not it. So in this case, once again, writing the same thing. You don't have to write it twice, but it's 3 pi over 4 or 135 degrees. Okay, let's move on. So the short way on doing this one is to look on the unit circle and find it, and let's kind of have a shortcut. Negative, negative puts us in quadrant 3, right? So negative, negative, and I'm looking for negative 1/2 comma negative square root of 3 over 2. So here it is, and I end up with 4 pi over 3 or 240. We know the answer, that's what we're aiming for. Let's do it the other way for when it's not always that easy. So a little bit of graph here, and negative 1/2 negative square root of 3 over 2, so it goes through there. And maybe it doesn't stop, maybe it just keeps on going, but that's not necessarily the point. We're going to swing this thing around, and we're looking for this angle. And this angle is based on the fact that this is negative square root of 3 over 2, and this is negative 1/2. So up here, let's switch colors again. Tangent. The tangent of our angle is from the origin, as the origin is the angle itself, it's coming from the origin. Opposite, which would be negative square root of 3 over 2, over adjacent, which would be negative 1/2. And there's a whole lot of canceling you can do here, and you can do all kinds of fun stuff. So the 2's cancel in the denominator, the negatives cancel, and you're left with square root of 3 over 1, which is the square root of 3. So what I really want to know is, where is tangent equal to the square root of 3? Tangent is equal to the square root of 3 here. Okay, well that's great, but that's not where I'm looking for because I've already drawn a picture. I know it's down here. So also here, there it is. And so the answer, again, is 4 pi over 3 or 240. So if you're like, man, I could have just found it. I hear you, but the next one's not going to be quite that easy. So we are finding where the tangent is square root of 3, which is at 4 pi over 3, also known as 240 degrees. All right, so there we go. It works lovely that way. Really quickly, I want to show you one other method of doing this that doesn't always work too well, okay? So you can use Desmos, you can use this graphing calculator. I'm going to go into degree mode, press mode and do that. Also, if you're on Desmos, you can click the little, I think it's a wrench or a gear or whatever, and change it, it's top right if I'm not mistaken, and change it to degree mode. And if I solved this, what's this? If I solved this, what I would be doing was doing an inverse of tangent. So this is really an inverse tangent of the square root of 3. That's what it is. So inverse tangent of the square root of 3. Oops, don't need that parenthesis. And I got 60. Now, and that's fantastic. That told me the wrong one. But that did give me kind of a jumping off point. So I could say, oh, well, it's 60 degrees, but it's not really 60 because I knew that it was down here. So this is actually 60 degrees away from 180. This is a 60-degree angle from here to here. So I could do 180 plus 60. Please do that in your head. You'd get 240. Okay, another way of doing it. Let's do the next one. Do a little bit of drawing. We have a negative and then a positive. So we're going to be negative 1, positive square root of 3. So negative 1, positive square root of 3. And that means that our angle, we'll switch to green here. Our angle is going to go through here. There we go. Too many dots on this page. There's one. Way too much going on there. All right, so this measurement right here was negative 1. This was positive square root of 3. And good luck trying to find that on the unit circle. You're not going to find this specifically here. But we can continue with this process. So tangent is, here we go, opposite over adjacent, and using this angle at the origin, we can swing it around this way, we can talk about it being here, you can have it from all kinds of perspectives, but ultimately the angle is from the origin. Opposite over adjacent, and that gives me this. So if you want to take this and kind of write it one more time, you don't have to, but you could. You get this. And then the next step, if you're going to do this in the calculator, would be to say, well, I don't want tangent, I need to undo a tangent, so I'm going to do an inverse tangent, parentheses there if you want to, and you can type that in the calculator, and you'll get the answer. Or you can come back up here and look on the unit circle and say, all right, now where is tangent equal to the negative square root of 3? They won't always be this clean, but for now they are. Where is tangent equal to the negative square root of 3? Oh, it's here. Now, it's also here. But let's be realistic. We have the option of a couple answers, but not really because we already know the answers in quadrant 2. So here we go. 2 pi over 3 and 120 degrees. So my final answer is 2 pi over 3. Also could be 120 degrees. Either one of those. I should put the word or in between them. Or, there we go. And just to do it on the calculator, I'm going to type it in this way. So the inverse tangent of the square root of 3 is 60. Nope. It's negative square root of 3. Sorry, let's fix that. Negative 60. Ooh, all right. Tricky, which means it would take it down 60. So it's here. So I also need to consider the other place as well. So tangent is always going to follow through the origin. So if I have an answer here, I have an answer here. It's going to be like that. Okay, last one. And this one's going to work out very neatly. It's kind of neat. So let's draw. It's going to be at 5, negative 5, which puts it here. So 5, negative 5. And here's our angle. Angles in the standard position always start on the positive end of the x-axis and swing around. So there's your angle. And so what we really have is the tangent of our angle equal to, so from this angle, call it here, call it around, call it whichever way you want to from your perspective, but ultimately we're coming from the origin, opposite over adjacent, which is, well, -5/5 is -1. So we're really dealing with the tangent is -1. So type it in the calculator if you like. I'm going to inverse tangent of -1, and I get -45. That's not an answer that you want to put. What we could do is add 360 and get the answer that we want, right? But otherwise, we could also say, well, where is tangent -1? And that's here, so it's there. It's also here. So instead of using the calculator, if it's on the unit circle, we can just look on the unit circle. So here it is. This is the one we want. We don't want this one because we've already graphed it and it showed up here. So it is 7π/4 or 315 degrees if we want to do both of them. So here we go. 7π/4 or 315 degrees.